bring you back, and think if this can take me less than 30 seconds, to some factoring notes. When we did factoring special patterns, these notes. Remember I added these examples and I made us fill in the blank for what the missing term was, right? So the square root of this is x, the square root of this one is 5, so the middle term is double that, 10x. Okay? And then I had you guys figure out what this last number was, so that the square root of this is x, and the square root of this needed to be 4, so that double that would be 8x, so we made that a 16, right? We're going to be doing a lot of this coming up with that third term today to make this a perfect square trinomial that is factorable into x minus 4 squared, or x minus 4 times x minus 4. Okay? So we've sort of done this already, but I'm going to start by telling you that there's two formats for parabolas, and we obviously spent all of yesterday looking at this one, y equals ax squared plus bx plus c. That's your standard polynomial format. So that's your standard format, and we get the vertex by doing negative b over 2a and then plugging it back in. Okay? And c in this case gave us the y-intercept, which we talked about. A tells us about opening up versus opening down. Okay? So we know how to use standard format. The other format is called vertex format, and that's what we're going to be working on today. So write this down. Y equals a parentheses x minus h squared plus k, and that's called vertex format. That will be a flashcard. You have to know that format. It's so much easier to find the vertex when you have it in that second format, because the vertex is just h comma k. Whatever's in the h spot is your x coordinate of your vertex, and the k is the y coordinate of your vertex. So if it's in that form, finding the vertex is super easy. Just look at it. Does this make sense so far? Okay? So we're going to start in this first exercise with something that is in standard format, and I'm going to teach you, this is really the majority of the biggest key on your homework, I'm going to teach you how to transfer that into vertex format. Okay? So I'm going to rewrite it down below so that we can work off of it. The first thing you always do is get rid of your constant. So this 18, I need to subtract it over. So subtract over your 18. And we're here. Then I need to make the right-hand side into a perfect square trinomial. Make it a perfect square. Hence the title, Completing the Square. What key number would I have to add here that's going to make this a perfect square trinomial with that special pattern we had talked about? 16. And Brock, how are you getting that? Does anyone know how to get it? What the shortcut is? Because you've done this before, Maggie. Right, you take half of the b number, so I'm going to write this as a note on the side. You take half of your b number, which in this case would be a negative 4, and you square that. And that gives you the magic number sort of to add to both sides, so 16. And if you add 16 to the right side of an equation, and you want it to still be an equation where they actually equal each other, then you obviously have to add 16 to the left. So the left-hand side's easy, it just becomes y minus 2. The right-hand side, the whole purpose of making it a perfect square was so that we could write it as something squared. So we need to factor this now. What times itself gives us that trinomial? It's got to be a binomial. X minus 4. Very good. X minus 4. times x minus 4. If you kind of checked that and FOILed that, you would get that trinomial. Good? Then you move your constant back over, so you add 2 to both sides. Okay, now compare what we just got there with the format at the top of your paper. What is my value of A? What's in the A spot? What number? Technically a 1, right? What was A to begin with in our standard form? 1. That should be the same in both places. Your A value should not change. What number is in the H position? Is it 4 or negative 4? The negative belongs to the formula. The H has just been replaced with a 4. So H is 4. What has replaced the K? 2. So HK is 4, 2. That's your vertex. Okay? Vertex equals 4, 2. Okay? Now, let's plot that. Vertex at 1, 2, 3, 4, and then 2. And then with an A of positive 1, does this open up or open down? Opens up. So just estimate kind of the opening up from there. And that's the function we just wrote. That's the graph of this function. And it's the graph of this function. These are the same two functions. It's just they're in different formats. Does this make sense? Okay. Now let's switch our vantage point for a second because it's important that you pick up on something else here. Think about parent graphs. This is your parent graph. Yes? And this is the graph after a transformation. What does subtracting 4 within the function do? Horizontal shift right 4 units. And what does a plus 2 do? Up 2. So can we all agree here's the parent function, y equals x squared. It just got shifted right 4 units, up 2 units. Okay? So someone else in the class earlier today asked a great question. They're like, so when you go to get HK, is it always the opposite of this sign and then take the K exactly as you see it? Right? Because most of you look at this and you see negative 4, correct? But the H value is actually just 4. And you see 2, the K value is 2. Okay? And the answer is yes. You always take the opposite of whatever sign you see there for your H and then keep that exactly as is. And the reason for that is kind of the same reason we focused on horizontal movements when it came time for transformations. Horizontally, everything is backwards, right? So even though we see negative 4, it moved it right 4, so our coordinate is a positive 4. Does that make sense? There's definitely a link there with that. So that's all of the first example. We've done everything. Any questions on that? Okay. We're going to do it again down here. How is this? Maybe you won't be able to see exactly. Any guesses as to how this one's going to be slightly different?